Meanwhile, in the Smash Tower.
Oh, hi. You've caught me staring at the sun again. This time in 193 angstroms. We see a diffuse coronal hole system in the center disk here, as well as one down here in south magnitude east longitude. South latitude east longitude, rather. No sunspots, and very low levels of solar activity. Here's a 304 angstroms view, and we see some pretty crazy filament activity. Let's zoom in on that. And we're looking at about 12 hours of activity here on December 3rd. Some filament eruptions up in the northwest as well. Here's a view of that. By the way, if you need a medic and you're wondering what we're listening to Power Bait, available at the SoundClick page. Check it out in the links below the video. soundclick.com/GoldenCatProductions. And now we've moved on to HelioViewer, and we're going to show you a fade of the magnetic fields. There's a magnetic environment. Again, no sunspots. And here's the fade between 171 angstroms and the magnetogram. Let's look at some more data. Here's a GOES X-ray flux, and it's completely flatlined. No surprises there. Solar wind, extremely low levels here. So we see a phi angle of 96 degrees. Solar wind density of 4.51 protons per cubic centimeter. The solar wind is made of 90% protons, folks. And solar wind speed, 304 kilometers per second, practically as low as it gets. And we're going to be making at least 2 more videos today, folks, or at least 1 more after this one, as there's too much stuff to cover in one video today, so we're keeping space weather separate from the rest of our content. Here's the magnetohydrodynamic pressure, and it's looking weak. Since it refreshed, we'll just let that play all the way through. So very weak magnetohydrodynamic pressure here. Not a lot of induced current as a result of solar wind. We'll look at ground magnetic perturbations in a minute, but first we're going to talk about the space weather modeling framework. Now, if you want to check this out yourself, just go to this page with the Geospace Magnetosphere Movies, scroll down, click on the Details tab, and then click on Space Weather Modeling Framework. You'll get this page. And going through the links here, there are a ton of different links. So feel free to read up about this to figure out where the data is derived. It's derived from a lot of different sources, everything from the X-ray flux to magnetometers, ground-based, space-based, proton counts, solar wind speed, solar wind temperature, all that stuff is all figured into the space weather modeling framework, folks. Any questions, feel free to email me. Here are the ground magnetic perturbations, changes in the Earth's B field, the B field being the field going through the magnet. And there we see some perturbations in the North Poles. And when I say North Poles, I mean that there are 2 of them. And perhaps even the South Pole is splitting in 2 here as it creeps into the Indian Ocean. Again, not a lot of current induced there. It looks like the majority of it in the north is actually over the net pole, which is going to be east of Greenland. Let's get back to data. Well, not that that wasn't data, but 10.7 centimeter radial flux holding at 70 solar flux units. as solar minimum conditions persist. And the magnetometer is having trouble drawing. There we go. And the magnetometer is looking pretty smooth here in a fairly normal range. Nothing to write home about there. And here's the reasoning. We are solidly in the South Pole oriented portion of the current sheet, shown here in red. Let's bring up a different view, as one of our viewers was interested in it. And this one is the line of sight ecliptic plane field plot. And this one shows you the best view of how the B field is affected. And you can see it's showing red in the foreground here. It's a great three-dimensional view of the current sheet. And again, we're solidly in the South Pole section here. No expected changes to happen that anytime soon. And that blue line, that's kind of the net field there. We won't get super into the magnetohydrodynamic physics, as it's got to be a short enough video to get it up quickly enough to be relevant. And here's the line of sight field plot also. I figured I'd throw this in. This one shows you the solar polar fields as well as the B field, which is the interplanetary magnetic field on which you live. Please leave a comment if you're viewing from a different solar system, universe, galaxy, plane of existence, spacecraft, etc. KP index is at 0 for a solid 24 hours, folks. And let's do the cosmic ray rundown since we see a full 24-hour KP0 day. Here's the data from Apatit and Barentsburg. Next, we've got Athens, Greece, Governor. There's the Athens Cosmic Ray Neutron Monitor. By the way, we've left links to this page that has all the cosmic ray sites. Let's go to Mexico City next. And there's the Mexico City Cosmic Ray Observatory. Moscow's been showing some wild swings, and the highest neutron count in the past 30 days just happened on November 30th. And finally, here's Oulu, Finland, as well as 2 Antarctican monitors, DOMC, shown here, and DOMB. Not a lot of data from that. Again, links to this site with the Cosmic Ray Stations network linked below the video. There's the GOES electron flux, and this is the kind of the normal portion of the electron flux. And we like what they've done with the new graphics. Well done, Space Weather Prediction Center. They've even drawn in the alert threshold line. And our patrons are aware that we send alerts manually to our patrons. Not yet automated that system. Relativistic electrons have finally found the bottom, and it's right in the middle of their recent range. Relativistic electrons, we don't expect to see many significant or abnormal GPS errors. As a result of this, let's look at the ionosphere, as we've been seeing anomalies in the South Pacific over the past 2 weeks. Thought we already had it loaded, folks. I apologize for the delay. And here's 6 hours of ionosphere data. And we continue to see those nighttime charge-up anomalies over the South Pacific, south-southeast of Hawaii. And let's bring up the latest image here and keep moving on, as we got to get the video produced. And yes, folks, we will return to live streaming. But until then, thanks for attending the premiere, all of you who did. The latest image of the ionosphere is looking pretty normal. Let's look at earthquakes, as we did see 1.6 magnitude quake taking place, I believe, at Chile. Let's just go up the list. I'll slowly scroll here. So we see a deep quake here in India, that one at nearly 200 kilometers at a 5 magnitude. There's a deep quake in Alaska. That one's only a 3.4 magnitude, 125 kilometers depth. A couple Japanese quakes there, nothing to worry about, as their buildings are well built in the country of Japan. And for that, we thank you. Papua New Guinea showing a 5.3 magnitude, 100-kilometer depth quake there. Heads up there for a larger quake at the surface, perhaps. And here's the 6.0 at Chile. Let's zoom in. And there's a location of that one, right off the coast of Arica, right near the Peru-Chilean border. There's a location of that. And let's head back to the list. A couple more quakes in Indonesia there. That one there coming in as we did show prep. Now, let's talk about Sanjiang Api real quick. I put a heart on it as it's as we're putting in certain favorite places on windy.com for obvious reasons. If you're interested in where the volcano Sanjiang Api is located, that's where it is. If you're on windy.com, just hit Control F and type in Sanjiang Api. Anyway, there's a location of that. By the way, windy.com has a fantastic mobile app also, which you may be interested in. It's free. And you can even do stuff like look up sulfur dioxide mass. That is a volcanic gas, if you weren't aware, folks. And perhaps some of that sulfur is emanating from Sanjiang Api there, as that is an unpopulated region, and populated regions produce sulfur also. But volcanoes, yeah, volcanoes. Cheers. And now we're back to looking at pressure. Let's look at the worldwide map here as we show the pressure maps each day for all of you home earthquake forecasters. Thanks for understanding the way these things work. And if you look at all those webcams, by the way, those are all webcams in there. You see those green cameras? So windy.com is one heck of an app. And the desktop version is a little different. Highly recommended. Let's play the pressure. We'll let about 24 hours elapse here. And we made the video at, it's already 7:19. Do you know where your pressure is? And there's where things will be in about 24 hours. And we see a volcanic uptick going on, folks. Lots of volcanoes on the list. Let's run down. The volcanoes. Mount Aso is possibly still erupting. Sakurajima exploded. Flight level 12,000. Mount Ibu, flight level 7,000 there as explosive activity continues there. Sanjiang Api, minor emissions, but enough to produce an 8,000-foot ash plume. Please don't pole vault Sanjiang Api, as it is a very uninhabited island, it looks like, and you will not be receiving medical attention for falling in the caldera. Mount Takono, continuous emissions, and a 7,000-foot flight level there. Popocatépetl. Looks like Popocatépetl chilled out. Now, Santiaguito in Guatemala has been exploding, producing a flight level around 11,000 there. 11,000-foot ash plume, that is. Pacaya in Guatemala, one of the Mayans' favorite volcanoes, erupting properly with strombolian activity, lava flows, etc. A 250-meter lava flow, that is. Not sure the flight level there, if there is one. Fuego, back to erupting there. Flight level 16,000 or so. Revenador, exploding, 15,000-foot ash plume there. Sabancaya, exploding, flight level 24,000. Nevados de Chilean, exploding, 12,000-foot ash plume there. Please do not do the Fosbury flop over Nevados de Chilean. Here's the solar system model. There's where we expect things to be in 7 days. They better be, as a full moon approaches. Mercury just rose. What do we have here? Mars and Mercury just rose. I use in-the-sky.org for my sky map. And let's do our daily star study. Today we're going to be talking about Gliese 570 ABC, an interesting trinary system consisting of 2 red dwarfs orbiting an orange dwarf and a brown dwarf. So the brown dwarf's not actually considered a star, folks. And For all of you Nibiru enthusiasts out there, I would note the fact that we can see a brown dwarf in a system 19 light years away. Do you think we wouldn't be able to see one in our own solar system? Don't talk crazy. Nibiru. It's not a thing. Anyway, we've got the primary star is the orange dwarf star, and then there's a binary system of 2 red dwarfs that orbits that, and then there's also a brown dwarf out there somewhere. A brown dwarf is kind of like a failed star, something in between a star and a planet, and we won't get into the classical cosmology descriptions of it, but if you'd like to read more about Gliese 570, we've left links. We got some power outages going on in the US right now. As if Jersey wasn't a crappy enough state already, 50,000 people are lacking power there. We've also got 18,000 out of power in Pennsylvania and another 12,000 out in New York. So we got some traffic snarls too. And check it out. I mean, New York City's always shattered at this time of day, but for some reason, there we go. So probably snow-induced travel problems, folks. Doesn't look like a good day to be in Providence or New York, although the traffic always sucks there, as well as Boston. By the way, if you want to see what the traffic is going to be ahead of you, head to Google Maps, maps.google.com, and click on the traffic layer. It might save your bacon from being stuck in traffic. As you don't want to be stuck in traffic, folks. Trust me, it's a strategic and tactical failure. And when you're driving, if your strategy devolves into tactics, you have failed at driving. Trust me, I'm a pro. Here's a lightning, by the way, at lightningmaps.org. And please leave a comment if you're viewing the video during the perfect storm in the Atlantic Ocean on a boat with a bunch of hunks resembling people like Mark Wahlberg and George Clooney. Leave a comment before a rogue wave drags your whole boat to the bottom of the ocean in 4 seconds. Here's the U.S. Doppler radar. Courtesy Weather Underground. Shout out to Weather Underground. Good times. As it continues to snow in western PA, wintry mix in Iowa, shout out Aubrey and other Iowan viewers. We got a harsh wintry mix over eastern Maine there, New Brunswick area, etc. Shout out to Neil Thompson and the Electric View crew. Let's look at more value-added services. And here's the NASA GOES interactive satellite water vapor map, showing that that low has finally exited the U.S., and it looks like it's off the coast of Maryland now. Still some snow showers to follow that until the dry air pushes through. And expect a bit of cold coming, folks. It's going to be cold and windy where I am. And today's bike ride has already been canceled, as it was planned to go off-road. Don't destroy your trails by riding in sloppy conditions, as the people who built them will not be pleased. Have you had your cosmic ray dose for today? Well, if not, perhaps consider going out to Colorado, as we see a ton of parallel lines there forming perpendicular to the flow of water. Now, this is because of an effect we call the Hall effect. And this is the perpendicular currents of electricity that spill off of the main flow of current. And looks like an interesting day for cloud formations, to say the least, over Colorado. Please leave a comment if you've got some interesting photos. Now, cosmic rays are involved in the creation of low clouds. I would note that the entire Gulf of Mexico, well, about half of the eastern half of the Gulf of Mexico, and the entire Atlantic seaboard is completely covered with low clouds. And we're looking at the NASA GOES shortwave radiation map here. This is 3.9 nanometers. And let's look at this area over the southern Rockies. As it is not yet light there, but look at those low clouds just hanging out. And that is the sort of thing that happens, folks. And we're not going to get into the atmospheric physics of it, but at least not in today's video. And you can see these higher clouds here. These are all low clouds in this area. All a feature of cosmic ray flux. And here's the cloud layer over the mid-Atlantic region. You can see that strong rotating low. Again, off the coast of Maryland, Delaware. Looks like it's moving south a little bit, folks. And check out these lines of clouds coming in here. Yeah, the Hall effect in full effect, folks. Next, we'll head to nullschool.net, look at the jet streams. Extreme meridional jet stream flow here, especially over the North Atlantic. They're going to be stating, oh my gosh, Greenland's melting and the UK is on fire because there's warm air being pulled up. It's put it this way. Watch our second video today. There's going to be a lot of climate nonsense on there. Anyway, here are the jet streams in the eastern world. Are you aware that it's Giving Tuesday? Would you like to know what YouTube gives us? YouTube gives us exactly nothing for the making of these videos. Now, we know that you see ads when watching our videos on YouTube, which suggests to people that we are paid to make this content. That is not the case. We're not going to get into the specifics, but the real funding of this channel comes from our patrons. So thanks for being associate producers of the show and the rest of our content as we do daily space weather videos every single day. We haven't missed a day for several hundred videos. And watch our channel continue to grow with the support of our patrons. Patreon.com/smAsho, the real funding of the channel. As again, YouTube pays us precisely zilch for this content. And thanks, viewers, new subscribers, etc., for tuning into the content and viewing the premieres and all of that sort of stuff. We appreciate all of your interaction greatly while we are at the ground level of our operation. And with zero warning, we've moved on to the bonus features. We're looking at our local yellow dwarf. If you've got messages for the sun, please leave them in the comments. Perhaps we'll read them at a later time. Perhaps the sun is reading them as you type them, or perhaps it's reading them as you think them. Anyway, here's the 94 angstrom view of the sun. See that North Pole coronal hole, as well as some magnetic complexity there. Two little spots of magnetism rising there, I'm sure, as well as one setting over here in the west. Solar activity kicking up. Welcome to cycle 25 and indeed the neo-renaissance. Here's the South Pole region. And we've got an additional bonus feature. It's the 131 angstroms view. There's the South Pole region complete with date stamps. You can see that filament there in the southeast near my pointer. Thanks again for tuning in, everybody. We greatly appreciate your support. Here are wind maps and shots of our star. Oh, wait, that's not right. Yeah, when you're staring at the sun, don't drink, and if you drink, stare at the sun anyway. Eyes open, no fear. Wait. Eyes open, some fear, as no fear would be irrational. Anyway, cheers, everybody. Welcome to the neo-renaissance as astrophysics and cosmology get rewritten. And since it'll never be now again, may that solar wind over there be at your back and that atherosclerosis absent from your veins. And yes, I am wearing Heat Miser's hat.